Welcome to Fortify Unplugged. In this video, we'll show how you can integrate Fortify static application security testing into your GitLab CI/CD pipeline. GitLab is one of the most popular source control management platforms, and recently they've been augmenting their DevOps capabilities to add native CI/CD pipeline functionality. Fortify has an out-of-the-box capability to integrate with virtually any CI/CD system on the planet, and GitLab is no different. So let's dive right in and show you how to use Fortify's reference templates to easily integrate Fortify static scanning into your pipeline. To begin with, you'll want to go to our Fortify GitLab CI/CD templates repository. From here, this is where we publish our reference templates that you can include directly or use as a documentation source to build out your own customized pipelines for integrated Fortify scanning. These templates will represent a growing repository where we will build out and add more and more capabilities. Currently, we have two templates available for static analysis with Fortify On Demand, our SaaS platform. We also have a static analysis template that uses the Fortify Scan Central platform for on-premise scanning. Within each of these YAML templates, we follow the standard definition that GitLab uses to specify jobs. So in this case, we've included some recommended documentation and guidance on how to incorporate these and what values you need to set within the particular job. In this case, the Fortify static analysis job. To begin with, it uses our Fortified CI tools container image. This image is publicly available on Docker Hub and can be used for a variety of systems, and it works very well with the runner-based implementations that GitLab uses. In this case, we can use either the hosted runners by GitLab, if that's something your organization has purchased from them. You can also leverage self-hosted runners as well and pull the Fortify CI tools image. When including these templates, we provided a set of default values that both serve as a representation of a common configuration and also allow easy overriding to customize to your needs. The two main steps when performing a static analysis with Fortify On Demand are to package the code and then to upload it to Fortify On Demand. This package arguments description, it uses our Fortify Scan Central client to prepare the code and its dependencies to get a robust analysis by Fortify. In this default case, we're using Maven, but if you're using Gradle or other build tools, you can specify those here in the package options. Additionally, you will see that there's a collection of Fortify On Demand environment variables to be set, including the data center you want to upload to. By default, we use the Americas environment, but you can override this to say the EMEA or APAC or other environments that we support. You can also customize the invocation of the uploader utility to meet your own personal pipeline needs, or for example, the notes field. When it comes to actually executing the job itself, you'll see it is just those two steps of invoking the Scan Central packaging client and then uploading code to Fortify On Demand. Additionally, keep in mind that there are some other variables here that you need to specify. So we can see that there are credentials that must be present, the Fortify On Demand tenant, the username, personal access token must be provided, as well as the release ID. These are available from within your Fortify On Demand tenant and should be specified as CI/CD pipeline variables in GitLab. Now let's show you how to do this for a reference implementation. We'll use our standard trusty 8-ball project to demonstrate how to integrate. So as mentioned, GitLab uses a standard YAML format to define their CI/CD pipelines. So let's drill into this example. Here, we've specified to directly include the templates as provided by Fortify directly from our repository in GitLab. There, we simply invoke the Fortify static analysis job. What's interesting here I want to call out is that we have adjusted the uploader arguments to overwrite the default values. In this case, we're going to pull the Fortify On Demand API and wait for the scan to complete with the -I option. And we're also going to specify the APF option or allow policy failure. As a development team matures their secure development practices, you may want to end up removing this APF flag, which will support more break the build style operations where critical or high or other vulnerabilities will actually cause your pipelines to fail. When doing that, you'll also want to set the allow failure to false. The other thing I want to point out with this configuration is that you'll need to think about your triggering events. In this case, for the demonstrations, we're using the when manual flag to be able to manually invoke the SAST pipeline job. As you begin to look at automation for DevSecOps teams, you'd probably want to look at triggering events such as merge activity on your master branch or other key branches. You might also look to invoke your static analysis based upon release events or perhaps on a cron schedule. All this is all part of the native capability of GitLab CI/CD pipelines. As I mentioned previously, you'll also need to make sure that you specify your environment variables. So to do that, we go down to the settings area and CI/CD. We'll scroll to the variables section. We can expand this and we can see those variables that were specified in the reference group. These must be present. We recommend using masking on the personal access token, tenant, and username aspect, as masking is also not supported in the release. To obtain these details, we'll pull them from our Fortify on demand tenant. So the release ID is available on your static scan settings page. So here we see an example of that configuration. The release ID is available on this page. This is what you'll configure in GitLab. The other thing you'll need to do is create a personal access token to authenticate by coming up to the personal access tokens section of Fortify on Demand, where I can create a new access token with the necessary API tenant scope, including whatever expiration date is appropriate for my project. I will then paste those back into GitLab, and we are ready to go. So I can because I'm triggering this manually on the job, I'm going to go to my pipeline section. I can choose to run a manual job. In this case, we'll invoke it here. So now we can see that I'm already running the job now. To begin, this pulls the Docker image, packages the code, and uploads it through Fortify on Demand. We can now see that the dependencies have been downloaded and the package is prepared, and we have then automatically invoked the Fortify on Demand uploader to start the scan through Fortify on Demand. The scan has successfully been uploaded, and because we specified the polling option, we will now wait for the scan to complete. The typical project in Fortify on Demand with automated audit has a turnaround time of about 10 minutes. So for your typical size project or smaller, this polling can be a great way of baking DevOps and providing direct feedback into your DevOps pipeline. And now we can see the scan has completed. The results are now pulled back into our GitLab pipeline results, so our team can see the number of findings broken down by severity, the policy, compliance, and well as a quick link to get back to the Fortify on Demand portal and start triaging and reviewing the issues. With this in hand, we've successfully demonstrated how simple it is to integrate static analysis into your GitLab pipeline using Fortify on Demand's reference templates. Thanks for watching this Fortify Unplugged video, and be sure to check back for future videos on how to integrate Fortify into GitLab and other DevSecOps tools.